Hello and welcome to lesson 3.1, increasing and decreasing functions. So let's first talk about what an increasing function is and what a decreasing function is. So recall, looking at the function on the right, that an increasing function is a function where if you have some value x subscript 1 and some value x subscript 2 such that x1 is less than x2, you'll see that the f of x1 value right here, and the f of x2 value, the f of x1 value is less than the f of x2 values, and this area is increasing. So as you can see, this red part of the function right here is the increasing part of the function. We often refer to it just by examining what the x values are. Now, likewise, a decreasing function, if you choose any values of x1 and x2 on the domain, so let's say x1 is right here and x2 is right here, you'll notice that f of x1 and f of x2 are these 2 points. So a decreasing function has x1 being less than x2, but f of x1 is greater than f of x2 for all pairs of x1 and x2 such that x1 is less than x2. So this blue part of the function is where you see this function is decreasing. Well, something else you might notice here. Now remember that increasing and decreasing functions matches to the derivatives. So derivative calculates the slope. Notice the slope on my left side are all positive slope, whereas on the right side we have slopes that are negative. So what you'll notice is that if you have an increasing function, then what you're going to notice is you have also a positive slope. And this is a direct relationship between the two. So if you have a positive slope, you can say you have an increasing function, and vice versa. If you have an increasing function, you have a positive slope. Likewise, if you have a decreasing slope or a decreasing function, you're going to have a negative slope. So what we're going to do is use our derivatives to actually determine where a function is increasing and where a function is decreasing. So let's suppose we have this function right here. Let's suppose f of x is equal to 3x squared plus 6x minus 5. So all we have to do is find out when our derivative is positive and where our derivative is negative. So coming back here, when f prime of x is positive, or when f prime of x is negative. So first off, we're going to find our derivative. We're going to apply our rules that we know to find the derivative. So derivative of this turns out to be 6x plus 6. Well, in order to find out when a function is positive or negative, it's very good to find out when it's equal to 0 first, because most likely it's going to change signs between values of 0. So we're going to solve this equation. So I know my function is neither going to be increasing nor decreasing at the value of x equal to negative 1. But we should check on either side of this to find out when it is positive or negative. So what we do is we use an interval chart. So I'm going to start by creating my interval chart. I'm going to look at x values less than negative 1, and we're going to look at x values greater than negative 1. Now, if your function is defined on a specific domain, then you'd actually specify the domain and you'd be going in between those values. So what I'm going to do is I'm going to analyze f prime of x for each of these domains. That's going to tell me what f of x is doing. So if I choose a value x less than -1, let's say x equal to -2, and I substitute it into f prime of x, I'm going to get a negative value. If I choose a value of x greater than -1, let's say x equal to 0, and substitute into f prime of x, I get a positive value. So what this means is, on the interval from x less than -1, we know f of x is decreasing. We usually use this short form, DEC. Another option, some people like to use a downwards arrow to represent decreasing. If the derivative is positive, like it is on the domain x greater than -1, then we know the function's increasing. So we sometimes use the short form INC or an upwards to the right arrow to show that it's increasing. So therefore, this function is increasing on the interval from x being greater than -1 and decreasing on x values less than -1. You should always state these domains that it's increasing and decreasing on, because the function might not be actually specified on a specific domain, or your interval chart might not be as clear as you might like to think. And because this is a quadratic, you know what 3x squared plus 6x minus 5 would probably look like. This makes sense. Okay, so let's try a function, another function, and see if we can figure this out. Okay, so again, we need to work out our derivative. So our derivative in this case would be -12x squared plus 12x plus 12. You can factor out a -12, we get x squared minus x minus 1. We need to find out when this is equal to 0. Well, if I divide both sides by -12, I still get 0 equal to x squared minus x minus 1. Well, this can't be factored, so I'm going to use quadratic formula here to solve for my values. If any values exist. So this is 1 plus or minus square root of 5 over 2. And you can find approximations, if you like, to these values. As I really don't need to find any approximations, but you could if you wanted to. I want to look at values before this and after this, and in between these values. So I'm going to create another interval chart. I know x being less than 1 minus the square root of 5 over 2 is one domain I need to look at. My next domain is I have to look between 1 minus square root of 5 over 2 and 1 plus the square root of 5 over 2. And I also have to look at x values greater than 1 plus the square root of 5 over 2. Again, I need to find out what y prime is. In this case, tell me what y is doing. Okay, so we need to choose a value less than 1 minus the square root of 5 over 2. I know 1 minus the square root of 9 over 2 is smaller. So that's 1 minus 3, which is negative 2, over 2, which is negative 1. So choose a value, let's say negative 1. Substitute it in. This will give you a negative value. So that means our function is decreasing to start with. Choose a value like 0 and substitute in. Your answer is going to be positive, which means your function is going to be increasing. Choose a value bigger than 1 plus square root of 5 over 2. Substitute that into y prime. That gives you a negative. So that way it's going to be decreasing. As you know what most cubic functions with leading negative coefficients look like, it looks like an S shape, like this, which follows the decreasing, increasing, decreasing part. And so, therefore, we found out where this function is increasing and where this function is decreasing. Again, you can approximate these values if you'd like. If you're going to approximate the values, make sure you approximate properly. Okay, so last thing. Let's suppose we're given a graph of f prime of x shown here. We want to state the intervals of increase and decrease for the function. So in actual fact, we're actually given already when the function is positive and where it's negative. We can see it's 0 at negative 5, at negative 1, and 3. We can see f prime of x is positive in this domain, negative in between, positive in between these two values, and negative after this. So if it's positive, we know where it's increasing. So it's increasing on the domains of x being less than negative 5 and for x values between negative 1 and 3. And we know f prime of x is less than 0. In other words, the function's decreasing on the intervals between negative 5 and negative 1, and for x values greater than 3. And that concludes our lesson.